Great. So if you wouldn't mind just starting off, let me know what is an NEC. I read your press release, but if you could tell me what you're announcing and what you're excited about this year.
Yeah, so today we're announcing a new network architecture that leverages the OpenFlow protocol to provide real network virtualization. So we are introducing a software controller and the first generally available OpenFlow enabled switch.
Okay. And so when do you actually plan to launch the products?
They are GA as of today.
They're GA as of today. Okay, great. Good to know. Now, OpenFlow and a controller-based module, would you compare it to like the Aruba does for wireless networks, managing a large number of access points with a single controller?
The goal really is to separate where the data goes on the data plane from the control plane, so that we can have a very fast path for the data, and we can have the network logic residing in the application stack, so that networking is managed just like any other application.
And so, exactly, so one of the big impacts from this, I think from an operational expenditure standpoint, is managing the network. And have you done any analysis, and what do you expect to be able to tell enterprises about the differences in operational costs in managing an OpenFlow controller versus managing, let's say in your data center, if you have 50 switches, managing each one of them individually?
Yeah, so what we found is that the amount of configuration for a large-scale deployment can be quite significant. In one customer's example, Genesis Hosting Solutions, they found that they were able to save 100 hours a month in network configuration by deploying programmable flow.
Yeah, I've been, the networking industry has been outside of the very largest and service provider environments, it's really been this hop-by-hop management paradigm where network administrators typically, console in or telnet SSH in and manage each node on an individual basis. And I've been, wondering and waiting for the time when we'd move towards a GUI and move towards a more streamlined and consolidated management system. It seems like OpenFlow is going to create that inflection point, so hopefully it'll take off.
Ease of management is one side of it. The other side of it is by having a central controller that can see the entire network, we can make better decisions about how data is passed across the network. So for instance, we have multiple policies for deciding where a flow is placed within the network, so that we can use all the capacity that's in the network.
Now, tell me about intelligence multipath routing. So traditionally, routers, switches haven't made very intelligent decisions about forwarding data packets. They're based on really static information, not dynamic information. How does the intelligent multipathing and work, and how does the OpenFlow controller change the way that packets are forwarded through the network?
Okay, so OpenFlow gives us the ability to collect statistics on all the network gear that's in the OpenFlow network, so that we can get a complete view of what's going on in the network, complete snapshot at any given time. And then based on that, we can make decisions to optimize where flows are placed across the network. So maybe shortest hop is going to have more flows on top of it, so we want to route around that. But we aren't constrained by any topology in order to make that decision.
Now, in your initial release, how intelligent is this routing decision as far as today, for example, if I were to create a bundle, an aggregated link, a group, you're typically hashing based on MAC addresses or IP addresses. So what can happen is conversations, if you have top talkers that are conversing, they may take a single path when there are multiple paths available. And in your initial implementation, how much information will the controller be able to take in real time to be able to adjust those flows for things like lower utilized links and so on like that?
So there's two models for determining when how a flow is placed. One is proactively. So if we push down a set of flows into the network for things that we would think would continue on. An example of that would be a DDoS attack, where you would always want to protect against that that would be a static flow. The other would be reactively. That is, when a packet comes in, we determine that this is a new flow, and then make a decision about how that flow gets placed across the network. So that can be real time, and we can scale that up.
Yeah. I think it's obvious, again, the networking world's been kind of waiting for data center bridging to ratify and for standards like Trill and 802.1aq. This is a different approach, as the forwarding devices themselves wouldn't have the intelligence. And so how do you see OpenFlow as a disruptor to Trill and 802.1aq initiatives?
So this is, we think, a simpler alternative that customers consider when building their data center networks. Because it's centralized control, you don't have to run the legacy protocols, you don't have to run these overlapping protocols. And because it's centralized, you also have a single API to connect to your other systems, so that you can begin to manage the network the way you're managing all your other IT infrastructure.
Now, one of the hot topics in networking is convergence and SAN convergence. So topics like fiber channel over Ethernet. A lot of the reason why fiber channel over Ethernet has been slow to roll out is because of the way that the packets need to be forwarded. So they have to be ordered, they have to have guaranteed delivery, and so on. And I think data center bridging is one mechanism of accomplishing that. And it seems like OpenFlow may have a different, with the intelligence in the forwarding, may be able to take a different approach at funneling fiber channel over Ethernet. Is NEC implementing anything for fiber channel over Ethernet?
So there is, in the OpenFlow standard, QoS capabilities. We're not announcing that during this release, but it's something we're very interested in and something we will be following around subsequently.
Very good. In this OpenFlow controller, I mean, we've talked about how it'll centralize the management, to centralize management console and streamline, a little bit about how it increases the intelligence and how packets are forwarded. What other, especially in your initial launch here, what other major features specifically that are different from your traditional networking paradigms that is the controller capable of?
So one of the significant features that we've added to the programmable flow controller is multi-tenancy. So customers can build complete virtual networks with separate layer 2, layer 3, and layer 4 policies by tenant. So customers can build these multi-tenant networks all on a shared physical infrastructure.
And the multi-tenant functionality is available within a single controller?
Yes.
Very good. Okay. And anything that you see real significant other than that feature-wise?
Well, we think it's the network. We think that to be able to have a topology-free network will allow customers greater flexibility on how they deploy network equipment. So today, placing a firewall load balancer often is location dependent. But with OpenFlow and programmable flow architecture, customers can bend the virtual wires and make those connections independent of where the physical boxes reside. And with multipath, they get the performance they need on the east-west route. So we think that this is a much simpler way to manage the infrastructure that customers have in place.
And that's one of the biggest challenges